All right, let's talk about tidying up. Not your closet, but your data. Today, we're diving into something called relational decomposition. Now, that sounds super technical, I know, but it's really just a smart way of taking big, messy data tables and breaking them down into smaller, cleaner, much more useful ones. Let's get into it. So let me start by asking you a question. What on earth does a junk drawer, you know the one, it's got dead batteries, rubber bands, maybe a few old ketchup packets, what does that have in common with a database? Well, it's simple, really. They can both turn into an absolute disorganized mess. See, when you just toss everything into one single spot, whether it's a drawer or a data table, you end up with chaos. It's just impossible to manage and a nightmare to find anything later on. And here is a perfect picture of that digital junk drawer. Just look at this table. Every single time a customer places an order, we're writing down their name, their address, all their info, again and again and again. All that repetition isn't just sloppy, it is a ticking time bomb. Because think about it, what happens when that customer moves? If their address is in there 5 different times for 5 different orders, you've got to hunt down and change it in every single one of those spots. And if you miss just one, your data is now officially inconsistent. It's wrong. You can't trust it. So what's the fix? Well, it's a classic strategy. Divide and conquer. This is where the hero of our story comes in. It's a process called relational decomposition, and it's the perfect solution for all this data chaos. At its heart, relational decomposition is just the process of taking that one huge, messy table and splitting it into a few smaller, really well-organized ones. It's like finally taking that junk drawer and sorting everything into a proper toolbox where every screw and every nail has its own specific compartment. It gets rid of all that repetition and stops those update mistakes before they can even happen. But, and this is a big but, not all breakdowns are good breakdowns. When you start splitting up your data, you get to a fork in the road. You've got to make a critical choice, and believe me, picking the right path makes all the difference. And those two paths are called lossless and lossy decomposition. Now, lossy kind of gives it away, right? A lossy split means you actually lose information in the process. You can't put the original table back together perfectly. And that's why lossless is the only way to go. It's a guarantee that you can piece everything back together exactly as it was without losing a single bit of data. So, how do you guarantee your decomposition is a good one, that it's lossless? Well, it's not some kind of magic trick. It's actually about following a really clear set of rules that make sure you get a clean, successful break every time. And to get it right, we just need to follow 5 core principles. Okay, here are the 5 big rules for making sure our split is lossless. First, you got to keep all your data fields. Super important. It just means no data gets left behind. Every piece of info from the original table has to have a new home. Second, you have to keep all your rules. Databases have these underlying connections between data, and those relationships have to stay intact. Third, and this one's huge, no fake data on rejoin. When you put the smaller tables back together, you can't accidentally invent new, incorrect rows of information, which leads to, number 4, don't repeat yourself. I mean, that's the whole point, right? To get rid of that mess we saw earlier. And finally, the ultimate test, you have to be able to rebuild the original perfectly. If you can do that, you've nailed it. That's a successful lossless decomposition. All right, enough theory. It's one thing to talk about it, but let's actually see how this works. We're going to take these rules and put them into action with a real example. Let's turn a messy table into something clean and efficient. Okay, so here's our before picture, the employee department table. You can see it's a mess. We've got employee info like their name and city mixed right in with department info like the department name. It's all just crammed into one big table. So now, using what we just learned, we're going to do a relational decomposition. Let's break this thing apart. And bam! Here's our first new table, the employee table. Look how clean that is. It has only information about the employee, their ID, name, age, and city. All that department clutter, gone. And here's our second table, the department table. See? Super focused again, this time just on department info. But look closely. See that EMP-ID column? That is the secret sauce. That's the key that lets us connect this table right back to our employees. Okay, so we've divided. Now comes the moment of truth. Can we conquer? Let's join these 2 tables back together using that common employee ID and see if we can get our original table back. And there it is. Look at that. The table we rebuilt is absolutely 100% identical to the one we started with. No data lost, no fake data created. This right here is a perfect, successful, lossless decomposition. It's beautiful. Okay, that's cool from a technical standpoint, for sure. But why does this actually matter in the real world? I mean, what's the big payoff for doing all this work? Oh, the payoff is huge. By doing this, we totally eliminate that wasteful repetition. We prevent those awful update errors we talked about. Our data suddenly becomes so much easier to handle and to search through. And what you're really doing is building a database that's tough, reliable, and ready to grow. You've literally gone from that fragile junk drawer to a professional, scalable toolbox. So I'll just leave you with this to think about. When you look at how information is organized, whether it's for your job or just in your own life, ask yourself, is it just organized for today, or is it actually designed for tomorrow? Thanks for tuning in.